Okay, great. Thanks. Right. So now there's as Adila said, there's a lot of chatter on these days on these topics, and mind you, some of it may be a bit exaggerated, some of it maybe not, but just to so just to have a perspective, so when you search a word cloud, so word cloud is also something that you will do in data science, but we will probably not discuss in detail today. But a word cloud like this actually shows some of the results, some of the prominence of the results that has been going on in the internet, right? So if you look at a word cloud related to data science or AI, you will get these kinds of words, right? So the size shows the prominence of the words. So you have data visualization, data mining, statistics, data structures, artificial intelligence, data engineering, all of these topics being searched for, right? So we will try to shed some light on these areas, more to say, so that you can get a basic understanding of where you will be heading, right? And as I said earlier, so this is important because this is considered the next industrial revolution, right? So if you are aware, so with the advent of steam engines and then mass production through computers, automation and all, so now we are entering the industry 5.0, right, so to speak, because now gone are the days now we use machinery and computers to build whatever the services and products that we need. Now it'll dawn into the age of human robot collaboration, or human AI collaboration, where things will be done. Now I'm sure that most of you, if a question is asked, if there are 50% in the audience, 50 people in the audience, 40 people will go for ChatGPT answers, right? Because I realized this when I was conducting a seminar last week. I asked to write a vision statement for their own company, and I realized that 90% of them were asking ChatGPT to do it. So whether that's a good thing or a bad thing, it's a different discussion altogether. But it's a convenient thing, right? That is what I think we have to take away from that. Whether it'll alter our perception or dull down our senses is a different story altogether. But as I said, so this will be the next evolution of, this will take off very fast, because mind you, even ChatGPT, if you really look at it, it's the very basic form of AI, right? It's called a narrow AI. So it's like an infant in terms of AI technology, right? So imagine when AI grows to a certain level, I don't know, as Adila said, there will always be two camps, and which side you're on will be, I think, determined by the knowledge. Also, I mean, determining factor for that will be knowledge as well, right? So the more you understand about something, I think the more you can benefit from it, rather than fight with it. So in terms of data science, what data science is it's an interdisciplinary field, right? So it's a combination of three major fields. So first one is maths and statistics, second one is computing, third one is domain knowledge, right? So domain knowledge specifically refers to the area that you're coming from, right? It can be business, it can be manufacturing, it can be banking, it can be medicine. So that is the domain knowledge. So we will, in the next few slides, I will try to go a bit deep into each of these areas and tell you what you need to know to become a data science enthusiast, or a data science analyst, or a data science engineer yourself, right? So data science, in my opinion, is simply an extension of statistics and mathematical analysis to data at scale, right? So that word is missing here, because you might know statistics a little bit, you might know mathematics a little bit. So you would know that you can do anything by hand, right? If you are given a set of data, you can do that by hand. You can do a statistical analysis by hand. It might take a longer time if you have, a set of 1,000 units of data. But here we are talking about data science, so that computing part will enable you to go beyond, not on thousands. We will be talking about data sets of millions and billions of entries, right? So that is what data science is. It's nothing new. It's simply application of statistics and mathematics at scale to data, right? So that scale comes from the computing factor. So that is where you have concepts like big data, processing power. So where you can extend the knowledge that you have in base mathematics and statistics into scaled up versions of applications, right? So that is all that there is to data science. But mind you, each of these aspects are deep on their own. So that's what we will discuss in the next couple of slides, right? So I just wanted to put this into context. Like, people often confuse themselves about, what is data analysis. I mean, what is the difference between a simple data analytic exercise and a data science exercise? So I just put together this just to give you an idea, right? So let's say, basically, if you have data and if you're trying to make decisions, if you're not trying to make decisions, then data analysis is sufficient, right? So that means you draw a few graphs and you draw a few charts and you say this is what the data is. It's a descriptive thing. So you don't need data science per se to actually do that, right? But if you are making decisions and if you have high volumes of data, and still you say you don't have high volumes of data, and if it's not uncertain, right? If the data is very, very finite, fixed, it's on a very, very, simple topic, then you can again get away with a simple data analysis exercise, right? But if you have data that is not of high volume, and that is also not, there's some level of uncertainty in it, and if that data uncertainty is significant, then you have to go for statistical analysis. So this is one part of data science. But as I said, if you don't have high volumes, there's no real point in calling that analysis a data science exercise, because scale actually matters. Scale is one of the governing concepts of data science, right? So branching from high volume, so if you say there's high volume, you need to prepare that data, right? You can't just take data out and start analyzing it. You have to prepare it some way. You have to put structures onto it, and then that whole effort, right? When you do that, when you take high volumes of data, you do that data preparation. It's actually called an ETL process, right? Extract, translate, and load. When you do that, and then when you start analyzing on that data, we call that effort a data science exercise, right? So this is just to put things into perspective. But as I mentioned earlier, people call, maybe even if you simply do a regression calculation, if you had done a regression calculation of 10 10 data entries, that also can be considered as a data science exercise. But one of the main points that I wanted to make here is that a data science exercise is characterized by the volume, right? So that is important. And when speaking about volume of data, we have this concept of big data, right? So we are talking about, especially in data sciences, we are talking about big data. And this data, I have a slide, maybe 2 slides away, that is talking about the growth of data. So the growth of data will actually exceed the number of particles in the universe, so to speak, within the next 20 years, right? The size of the data in terms of bytes, that'll probably exceed with the current growth rate, it'll exceed the number of particles or atoms in the entire planet, so to speak, right? So that's how how data is growing. So you can imagine why data science will be important, because when you are overwhelmed with data, the only way to make sense is through, right? So you have to go through the data and make sense of that to make sure that you can at least understand the context that you're in, or what actually is going on around you, right? So big data has 6 characteristics. Generally, some people say 3, some people say 6. So they talk about the 6 V's of big data, right? So big data is high in volume, right? The amount of data is very high, right? The variety in data is also very high, because it's a collection of a lot of data, meaning it can be structured data that is coming from databases. It can be unstructured data like documents and files. It can be any form of data. So the variety is also high, not just the volume, the variety, right? And then the velocity. So velocity is the speed at which the data is being generated, right? So that is also very high for big data, because it's not just a lump of static data. It keeps on generating, right? So that is the nature of, so these 3 are the base characteristics of big data. And when it comes to data science, typically we call data science, but I mean, if we analyze 1,000 data, 1,000-row data set, we call that data science at the learning process. But technically, you have to deal with big data to ideally call it big data, in the sense data that has these characteristics to call it ideally a data science exercise, right? So other than that, you have things like veracity, meaning the integrity of data, because just because data keeps pumping in, you have to make sure that the data is valid, right? So that's where statistics comes in. You have to make sure that you do central tendency analysis, inferential analysis, so that you can validate the data before you put that into a different sort of an analysis. Okay. And the value, right? Variability. So these are some of the important concepts when it comes to big data. So please remember, why I suddenly jumped to big data is because by definition, data science deals with big data, right? Because your computer, because data science without big data is just statistics, right? So without the computing element, because you need the computing element because of big data, right? So in the computing element, we will talk about things like programming. So you need you need to know data programming languages like R and Python, and you need to know data lakes like Hive, or maybe various ways of managing data like Hadoop clusters, Spark. So all of these things are there because you need to handle these vast amount of data, right? So if you can put something in an Excel sheet and apply statistical formula, that also is data science without volume, right? So as simple as that. So that is what you need to basically understand. So the point that I'm trying to make here is that to be a true data scientist or a data engineer or a data analyst, you have to have an understanding of all of these concepts. So I will again put this in a different perspective also for you to understand. So the bottom icons actually shows you the types of data, right? The variety of data that can be included in big data. So as I said, it can be structured data coming from data sources, databases, unstructured data like files, semi-structured data, geospatial machine data, things that are coming from IoTs or other computers, open source data. So any kind of data constitutes big data, right? So having understood the 3 main areas of data science, we will talk about those 3 things in a bit more detail. So those would be the 3 main pillars of any data science exercise, right? So the first pillar is math and statistics. So even though we might not like this idea, the basis of data science is laid, the basis of not just data science, but any any efforts in AI and data science is laid on maths and statistics. But this is not to say that if you're coming from a different background, that you can't be in this field, right? You have to have a basic understanding of maths and statistics, and if you can understand that very well, that's great, right? That will help you a lot in doing proper algorithm selections, doing proper analysis, understanding where problems go wrong. It's great, but this has been done for you in the computing part, right? So even if you don't really understand the core maths and statistics, you can still use the computing part of it, which will give you an abstraction onto these layers, right? So for example, if you want to do a statistical analysis on naive Bayesian, for example, right? To do a Bayesian analysis on 1,000 data set, it will probably take you somewhere around 3 to 4 hours, because it's that lengthy, because you have to calculate the Bayesian probabilities between each and every element. But if you take the software like either Python or R, it's just a single function, right? Naive Bayes, the function that you have to call with the data set, and it will give you that answer within maybe half a second. So that is where the beauty is. So even if you don't understand the core mathematics, but mind you have to understand what the applications of naive Bayesian, or what the application of that particular algorithm is, right? And how to use it. Maybe not, not understanding the mathematics of it is something that you can get away with, right? So the math part of it requires you to have an understanding of these areas, right? So you have to understand probability. So there is a fundamental thing, because that's how you explain the occurrence of something. You have to understand a bit of calculus, because there's something called a backward propagation algorithm in machine learning, right? So we will define machine learning next. So in machine learning, to understand backward propagation, you need to understand calculus, right? Differentiation, to be exact, or partial differentiation of cost functions, right? You need to understand that. And linear algebra is also important, because linear algebra deals with matrices, and a data frame is also a construct that resembles a matrix, right? So it has rows that will show you the observations, and columns that will show you variables. So understanding linear algebra is also a bit important. But as I said, you can get away with most of these, because they have been programmatized for you in the computing area, right? The differential equations is also another area, and geometry also you need to understand, because one area of data science is called unsupervised learning, which basically talks about clustering and things like that. So which is what happens in your, if you're using Netflix or Amazon or Spotify, the way that it basically characterizes your persona is through clustering, right? So it basically tries to put you in a cluster with similar interests, so that when you are part of that cluster, it gives you the recommendations of the movies or the songs that have been given to those clusters, right? So that's called unsupervised learning. So we will discuss that next. And the statistical part of it, so maths, you need to understand these concepts. Statistics, there are three main areas, right? So first one is called descriptive statistics, which basically talks about the central tendencies, or describing what is there, right? So it deals with things like mean, standard deviation, courteous, skewness, and all. So it's just a statistical analysis, a description, right? Then the second branch of statistics that are required for this is called inferential statistics. So based on the descriptive values, you can make hypotheses, right? You can say, if you remember the last slide, it talks about the value, right, and the integrity of data. So these things can be established by creating postulates or hypotheses and validating them, right? And you can try to fix through inference, you can try to fix data onto a distribution, right? So you might be well aware of the normal distribution, but there are about 14 main distributions, like the log distribution, t distribution, chi-square distribution, and Poisson distribution. So there are different distributions, because normal distributions will not fit all of the scenarios or all of the analysis that you're dealing with. So you have to make sure that to model, right? Because data has to be modeled, right? So that is another definition for data science, data modeling. So in order to model the data, you have to first try understand the data descriptively, and then you should be able to fit that into a model, right? So that part is called inferential statistics. So once you fit it into a model, the advantage is that you will be able to predict, right? So that is the third part of statistics that you have to learn, predictive analysis, right? So once you have the description, you will be able to fit it into a model, and then from that model you should be able to predict, right? So that is the understanding that you have to have in statistics, and unfortunately this is something that you can't get away with. This part you have to have a good understanding, because this is the sort of the core of it. Also, as I said, the math part you can work around, but statistics you have to have a deeper understanding, because you need to be able to argue with yourself or with your team to basically understand how to best describe a set of data that you have. And of course, nowadays the softwares actually there are maybe in any form there will be like 6 to 10 algorithms that you can test the data with. And luckily for you, even AI are now there that basically does all possible combinations of statistical applications to data, so that you don't actually have to do it. But mind you have to know how to interpret it, right? So that's what I said. So when you do a machine learning exercise, you will get a model output, right? And it will have different values, p values, degrees of freedoms, degrees of definitive. So you need to be able to interpret that. So that is where the inferential statistic part comes in. You can just do whatever the analysis, but the output, to explain the output, you still need to have an idea of what these are. So I'm pretty sure that if you're familiar with a data science exercise, maybe if you had done a bachelor's or a master's, you would have seen things coming out, right? Things being thrown out. If you say, for example, if you do a principal component analysis, it'll throw out a lot of values. So being able to interpret that comes out of the statistical concept understanding, right? So that is important. That is important to understand. So then these statistical concepts and the mathematical concepts are combined into an area called machine learning, right? So that is the core of the data science exercise, right? So machine learning basically, as I said, combines statistical methods with mathematical constructs and gives you functions, right? So machine learning is nothing but a function that you can use to describe your data. So within that function, all of these analysis will be done for you. So it will do a descriptive analysis, it will do an inferential analysis, it will do even a predictive analysis if it's able to predict, right? So some machine learning algorithms, so these are basically functions or algorithms, right? So those are the two keywords that you have to keep in mind when you're talking about machine learning. So machine learning is nothing but functions or algorithms defined through the use of maths and statistics, right? And you have to understand how to apply them, right? Say, for example, if you take a clustering machine learning algorithm, clustering cannot predict anything, right? But there are ways that you can use clustering to describe a set of data, right? So that is what you will basically learn in this area of machine learning. So machine learning broadly has 4 areas, right? One is called supervised learning. So supervised learning is basically used for classifications and predictions, right? So supervised meaning it's supervised on one variable, right? There's a supervision on a variable. So that means you are either trying to predict or classify, right? A variable. So some of the algorithms or some of the machine learning algorithms that you will come across in supervised learning are, regression, naive Bayesian, support vector machines, decision trees. So these are the stuff that you have to know about, right? So even you don't know about maths and statistics, you should know at least how to interpret these machine learning algorithms, right? So some of the applications of supervised learning will be medical diagnosis, right? You can train an algorithm to detect lung cancers, right? And you give it X-rays or chest X-rays, it can detect that. So, or if you can give, let's say, cancer detection, if you can give the features of a biopsy, right, or whatever the sample that they take, if you can give the features, and you can build a model for the computer to say whether some patients will have cancer or not, right? So those kinds of applications, it's supervised, right? So the output is a classification. So you have to get a yes or no as the answer. Or you can do value predictions, like, say, for example, sales or material predictions. So you can use a lot of parameters to predict your sales, right? So that is also a supervised learning, because you're focused on sales. Your supervisory variable is sales. So that is what is called supervisory or supervised learning, right? Then you have unsupervised learning. So the purpose of unsupervised learning are twofold. You either can reduce the data or reduce the amount of data, or you can do pattern recognitions within the data, right? So some of the algorithms or machine learning algorithms that you will come across in this unsupervised learning area: principal component analysis, k-means, market basket analysis, or association rules, right? So you can use it to do anomaly detection, data reduction, clustering, like in the case I told you about Netflix and Prime TV or Spotify. That's how these algorithms. Now, if you watch a movie, you will realize that next day when you log in, you will see a whole bunch of new suggestions for you. So that means the clustering algorithm is trying to place you with some other neighbor, and that neighbors or that clusters suggestions will also come to you, right? Or and a new cluster is created. So it's a whole different thing, but you will understand how those things work when you go deeper into this, right? And the third thing is called reinforcement learning, right? So reinforcement learning is you're basically providing a reaction, right? An action and a reaction. So this is basically applied in games, right? So chess games, go games, or driving, self-driving cars, because there will always be some kind of a sensor input outside, and based on that input, the algorithm will basically dish out an output, right? So it's not like the cancer case. So you have to understand that, right? So in the cancer case, if there are 8 parameters defining a sample or a cancer cell, based on the values of these 8 parameters, you will get a yes or no, right? But in reinforced learning, basically you will go through another analysis and give out an output based on an external stimuli, right? Or based on an external response. So here you will have to learn things like game theory, positive reinforcement, negative reinforcement, things like that. So it's like, the example that I can give you is like, for positive and negative, it's like training a child and training an animal, right? So when you're training a child, you can do positive reinforcement. You can explain to the child why something, if you do something good, you will get positive results, right? Similarly, the algorithm has to be trained that way. Negative uh, reinforcement is like training your pet animal, right, or pet dog, right? So if it doesn't do what you want, you can do a punishment and then enforce the positive behavior that you want, right? So that is called negative learning. So it's based on cost functions and linear algebra. So operational research and those kinds of things, specifically rooted in game theory, so that you can actually define the winning criteria, right, for reinforcement learning. And then there's another whole different subject. So this topic, even though I have given you this in this small box, this is actually the biggest area now in data science, but it's too big to cover in a discussion like that. So that is called deep learning, right? So deep learning is the learning associated with neural networks, right? So neural networks can specifically neural networks with more than one hidden layer, right? So a neural or a neuron basically has a input, a weight, and an output. So your input is multiplied by the weight at the output, right? So that is a simple neuron. But so that has one layer. So when you have multiple neurons, multiple layers, hidden layers, or multiple weights, right, in between your input and output, we call that a deep learning exercise or a deep learning algorithm, right? And mind you, deep learning can solve any problem, right? And there are pros and cons to it, because given a data set, a neural network will give you a solution. There's no question about it. But whether that solution is optimal, whether that overfits the data, so those are the things that you have to understand in dealing with neural networks, right? So neural networks, as I'm pointing here, can do anything. Right? It can do clustering, it can do prediction, it can do whatever anomaly detection. So anything can be replaced by a neural network. But tuning neural networks and optimizing it is very tricky, right? So that's why it's a new area that is coming up under the topic of deep learning. So deep learning simply focuses on the concept of neural networks with multiple hidden layers, right? And unfortunately, given this context, I'm not going to explain what these are, but probably I can share this presentation with you all. So if you want to go deeper into these areas, and mind you, all of these are like machine learning, supervised, unsupervised, reinforcement, deep learning. So these areas are separate modules, will be separate modules in a course, if not multiple modules, right? So that's how deep these topics are. So for example, the course available at Kensley, so you will see descriptive statistics one module, inferential one module, predictive one module, supervised one module, unsupervised one module, right? But reinforcement and deep learning you don't do at postgraduate level. It's sort of postdoctoral level research, but it depends on where you are going, right? What path you are taking in your career, right? So the pillar number 2, right? So this we talked about. So remember, what we are showing here is the pillars of data science, right? Maths and statistics, computing, domain knowledge. So pillar number 1, that's the basic discussion that we did. So in pillar number 2, we are talking about computing, right? So in computing, one of the first important things that you have to understand is programming, right? So programming basically boils down to 6 constructs, right? Variables, functions, data types, data structures, objects, and classes. So this is what you will learn. So this is what you have to focus on, right? Not learning either R or Python or SAS or SPSS or something like that. You have to understand these concepts, right? So any programming language, you will, if you have done, you will realize it's based on these 6 constructs. Not all 6 are available in everything, but at least the first 5 will be there in every language, right? So based on this understanding, it's good and not good, but you have to mandatorily understand at least some of these languages, right? Either R, Python, SAS, or SPSS, or there are other things like MATLAB, Minitab that you can also go into, and if you're familiar, you can use, because but R and Python are the most popular, and Python is becoming more popular day by day. R is a fundamental language, but Python is more of a user-friendly and a powerful language. right? SAS and SPSS are basically, it's like Excel gone to another level. You can select the data and then give the function as a it's sort of a GUI based programming language, so to speak, right? So either way, learning R and Python is also important, and that will be part of any of the data science courses that are out there, right? If not both has to be learning both is good, because once you learn one thing, converting to the other is very easy, right? And you have to focus on the concepts that are given, not on the language, right? You have to understand how variables are defined in R, how variables are defined in Python, how a function is defined in R, how a function is defined in Python, because end of the day you will be using a function, right? Neural networks is a function called NN. So you just need the data structures to be inputted into it, right? So that's how easy it is. But you need to understand what goes under the hood on a function, right? You need to understand what data types to give in, what data structures to give in, and things like that. Okay. So the second thing is visualization, right? Programming while computing is there for data science is for visualization. So visualization, these are some of the things that I know, right? But there are other things, there are many other things that can do the same thing. So you can do visualizations using Tableau, Power BI, Excel, ClickView, or Excel, things like that, right? So that is where computing comes in, because visualization is a major part of computing, right? Google Analytics, structuring. So so these are again, I'm saying stuff that you need to know in computing, right? So you have to know SQL, NoSQL, ETL processes, things like MongoDB, and also because we are talking about big data volumes, right? You can't have Excel sheets of big data. You have to put it into a database and then start retrieving in and out of databases, or combine databases into a data lake and start dealing with a lot of parameters. So that's how you need to evolve, right? So these are the areas that in computing that you need to go into, right? And then processing, right? So processing is also provided by the computing part. So in processing, as I said, this is nothing but scaled up applications of maths and statistics, right? So you need to be able to go into areas like cloud computing, because you can't run, probably if you have ever done it, you can't run a high level machine learning algorithm on a computer, right? It'll slow down, and it'll probably I have run some simulations which had taken nearly about 3 hours to give me a result. But then, of course, there are other processing platforms on clouds that you can use to get the same result with very high levels of processing power, maybe within a couple of minutes, right? And then you have GPU-based computing mechanisms that you can use to improve your processing, right? So when you do your studies, when you continue your further studies, you will see that when you have more data and more complex algorithms, like if you're running deep neural networks or deep learning, you can't possibly do that in a simple machine, right? And finally, you have to know how to handle big data, right? So in that, you have to learn things like data warehousing, data mining, data storage, data processing. So I have given some examples here. So you have to know things like Hive, Hadoop, Spark. So all of these things you need to learn from the perspective of computing, right? So in the interest of time, I'll just quickly run through. And domain knowledge is important because, as I said, it can be either in medicine, it can be in it can be in business, it can be in finance, it can be in banking. But it's important because you need to, when you're doing a data science exercise, an objective is important, right? You can't just do data science on data. You need to have an objective. What is the objective? Whether it's to find a fault, whether it's to optimize, you need an objective. So to come up with that objective, you need domain knowledge, right? You need to understand what is going on. So maybe if you have a data science background, and if you're asked to consult on a medical project which you have no experience in, Maybe for the domain knowledge, you have to consult a doctor, right? To understand how to set an objective, how a cancer is detected, right? Otherwise, you can't play with that kind of data. Domain knowledge is important for you to understand what are the sources, right? How to collect the data and how to pre-process it, how to model it, how to maybe select the proper algorithm. So whether you go for a Bayesian approach or whether you go for a classification approach, whether you go for traditional probability. So all of that, and then finally interpretation, when you do all of the data science, and if the result is not interpretable, right? Just because, that's what I said, if you plug anything into a neural network, you will get an output, right? But interpreting that is very crucial, because neural networks without interpretation is a waste of everybody's time, right? So be mindful of that. So anything can be plugged into a neural network to get an output, but interpretation is very important. You should be able to interpret your results, right? But that comes from the domain knowledge that you have, right? So as I said, it can be manufacturing, production, banking and finance, telecommunications. So the idea here is to take a real world problem and solve it, right? So that's why we are learning, right? Not to have all of these mathematical, machine learning and all of this in our heads. We need to be able to apply it and get a real world problem solved. So this is the function of a data scientist, right? Solving problems in data specifically. And when you solve problems in data, you will solve problems in other areas as well, right? So that is really important. So this is actually a bit of humor that I think that you will now be able to understand this. So now this picture says a lot, right? Humans are hooked on cell phones and machines and all of this, whereas the machines are learning, right? So the machine learning is something that will, as I said earlier also, mind you, machine learning is part of narrow AI, right? I'll show that relationship. So machine learning is an infant concept in AI, and imagine what it can do, right? You might have seen the chat GPTs and how the analysis is done, and how it basically shows you what how things are done. So this is a dangerous yet exciting concept, but that's how it is, right? So this is putting all that into place, right? The process, the methodology of data science, and mind you, it's not always about the mathematics and the blinks and the stars that we talked about, right? You have to take an extremely painful effort in preparing data, right? I will tell you, it's not glamorous, and those of you who have done it would agree with me. It's a tedious process, right? Because there'll be a lot of painstaking hours that you will have to spend in structuring data, getting the data, finding the missing values, and figuring out ways to fill out those missing values and see whether those extrapolations or interpolations are worthwhile doing. It's a huge task, right? So if you take these areas, right, the data collection, data understanding, and data preparation, this will probably take, I would say 70% of the time that you will spend in a data science exercise, right? The modeling part, the machine learning algorithm selection and evaluation of the results. So those things are pretty easy. Once you have the proper data structures in place, this is a piece of cake. Because as I said, it's just a single function call that you have to do in R or Python that will give you an output. And you can visualize that output and try to interpret it. But this data collection requirement, requirement analysis, this is very painful, right? Because end of the day, when you define an objective, there might be certain scenarios where you don't have the data, right? Then you have to go into deeper research methodologies like conceptualization, structural equation models, things like that to build concepts, right? Then it gets way too out of hand, right? So my advice for you is in dealing with data science, if you are currently doing it, make it simple, right? Use existing data. Don't try to fabricate conceptual constructs, because that will not end well end of the day, right? So I hope this is quite straightforward, right? You need a business understanding. That means you have to set an objective, right? And you have to define your approach. You have to figure out the requirement, you have to collect the data, you have to understand the data, and you have to process the data, right? To be loaded into modeling. So modeling is basically fitting algorithms. So machine learning is what comes in modeling, right? Then you do specifically machine learning and visualization, right? So once you do that, you do evaluation, you do deployment. That means you deploy the model into practice, you get feedback, and you keep improving this, right? So if one model fails, you try another model, and so on, right? Until you find the answer. So that's the thing. So there is no real correct or a wrong thing to do when you have a set of data, right? It comes through experience, right? What you need to do to data comes with experience. You will realize, okay, I need to do this kind of an analysis, I need to do that kind of an analysis, and so on, right? So prospects in data science. So mainly there are three categories: data analyst, data scientist, and data engineer. So data engineer is the one who builds the backend or the entire infrastructure part of it. So they will manage the Hadoops, the Sparks, the Hives, the computing, the cloud. So that's the data engineer's job. Data scientists will do the learning part, right? So they will extract data from the data warehouses and run machine learning algorithms on it using R, Python, SPSS, whatnot. And then that data will be passed on to an analyst who will actually structure it, do the reporting, visualization, and those kinds of things with the data. So this is the 2023 highest demanded jobs in IT. So you can see AI engineering, data scientist, data architect, big data engineer. So majority of positions in data science are here, right? So that means at the top end of the earning potential in the IT industry, right? So it's a good, as I said, it's a good thing that you are in the evolution into the industry 5.0, but it's a good thing because these are in high demand also, right? And these are some of the statistics that shows you what are the key skills that you will need, right? So here, so Python is the most popular one. Data mining is there. So this is again like things like R and Python. Data analysis, machine learning, you need 80%, right? So Python and machine learning combined can take you a lot of the way, right? Python, so let's say Python, machine learning, SQL, and R programming can take you a lot of the way, right? In terms of data science. So that is what will be the focus of any course. That has to be the focus of any course. So data analysis, of course, is the statistical part, right? So that also, so having these elements, so that this is what you have to look in a good course, right? So if you want to go into data science courses, look at these elements, right? SQL might not be that important, but SQL, of course, has some value, right? So this is what I said, right? So by 2025, it will be 175 zettabytes. So I think everyone knows here what a terabyte is, right? So a zettabyte is 1 billion terabytes, right? So 1 billion terabytes. So by 2000, that's what I said, by 2050, the number of data points in the world will surpass the number of atoms in the world. So this is a crazy growth. So this demand will continue to grow because making sense out of data will be the way to go in the future, right? So that is why this is important, not just because we say so, but because the data suggests the data has evidence, right? So I just thought of putting this. So if you are new to data science, you have to do fundamental learning and go into an entry-level job in data science. But if you are not new to data science, so this path is yes, this path is no, right? Sorry, I couldn't put that in. So if you are not new to data science, if you have done a bachelor's in data science or a master's, you can go into the industry, you can build a data science career, and you can end up as a C-level executive. So there are new positions coming up: chief innovation officer, chief data officer. So that's a target in your career path, or you can build your own consulting, right? You can help others to make sense of their data. So that is one other career path. Or you can choose an academic career path, right? So if you have done previous data science exercise, just you can do further studies and training. Then you can go into postgraduate research, and you can ultimately be a researcher. That's also a very high paying job, because that's to do research. That is to come up with new machine learning algorithms. That is to come up with new programming structures. So these researchers will produce the stuff that we will use in our data science careers, right? So that's how the cycle goes. So these are some of the parts that I wish to discuss with you. So then this is the next interesting thing, right? AI. So AI is simply defined as the ability to mimic human behavior, right? So anything that a human can do, if he can do that in a machine, that's called AI, right? And this is the picture that I found. I mean, that I thought this is the question. As I said, Adila also pointed this out, whether it's friend or foe, right? So whether it's the Terminator rising, or whether it's a friend in disguise, right? So this is I think the question that everybody has, and I also don't know where this is going. So in terms of AI, there are three main areas, right? Narrow AI, general AI, and super AI. So super AI is still a hypothetical concept. It's like the Terminator or this robot. General AI, now we are entering into general AI. So chat GPTs and all are at the start of general AI, right? So they are called generative AIs. So they are nearly there. They are the general AI where there is a small amount of sentience. Because why AI is dangerous is that if you directly ask even ChatGPT how to hack someone, it will not give you that. But you can fool the system, right? You can create a prompt saying you can ask ChatGPT to take the form of a hacker who does certain things. So when you create that prompt, ChatGPT will happily start answering it, right? So that's what's crazy about it, right? I mean, if you know how to hack ChatGPT, that is a dangerous thing, because it will start giving you crazy answers. So I did this with one of the prompts, and the answer that I got was scary. So I asked whether there will be a war, inevitable war between humans and artificial intelligence, and a ChatGPT prompt always says no, that is not possible. We are there to help you and all that. But the prompt that you create, the persona that you create, will say obviously there will be a war, because humans have done nothing to sustain this planet, right? So that scares the hell out of you when you're doing that, right? So I don't know. As I'm saying, I'm also new to this area, so I will probably know a little more than you, but I also don't know a lot. So this is pretty interesting, at the same time very scary, right? So I will probably skip these things in the interest of time, because now we have spent about close to about 40-50 minutes. So these definitions are there to categorize, right? So you have reactive AI, limited memory, theory of mind, and self-aware. So self-aware is still a concept that is not yet there. But reactive AIs are, now ChatGPT is a reactive AI, because you ask something, it will answer. Or chess. Limited memories, when you are driving, so you find out your environment and do that. So theory of mind, again ChatGPT has come near to realizing this, because these were mere constructs 5 years ago, right? Now they are becoming a reality. So that's the strangest part of it. And this is what I said. So other definition is, so you have narrow artificial intelligence, right? So this is the area to do with machine learning. So now you realize machine learning is a part of what? Data science, right? So this is where AI and data science interact, right? At the narrow AI or artificial narrow intelligence, right? So, but when you go into general intelligence, right, AGI, that's a different story. That goes beyond machine learning. That's so here we are talking about the concept of sentience, right? So sentience is the ability to feel oneself, right, or basically awareness. So awareness, this is coming up, right? So this, you can give awareness to chat GPT. You can actually, as I said, you can create a persona, you can create a prompt that is aware, right? So but it will only be aware of the data it has been given, right? So its awareness is only in the area of 2020 to 2023 maybe, right? So its awareness has not gone beyond that. So even we call ourselves aware, but we are also aware up until a certain event, right? Maybe we will know, before Christ or after Buddha. So those are the areas that we know. So our awareness only extends to that, right? So we are also not sentient in that sense. We don't know everything that happened from Big Bang, right? But one day this awareness will surpass ours, because a machine will be more aware than we are, right? If you think about it, right? Most of us might not even know 2000 years of history, and we know points, right? But a sentient machine will know everything that came to pass 10,000 years ago, right? And their decisions will be based on all of that. So imagine the power of that decision, right? So this AGI is an area. This area I'm also not very much familiar with, ASI and AGI. So those are very state of the art things. But narrow AI, I'm familiar with, because it interacts with data science heavily. Because narrow AI is built on machine learning, right? Mainly machine learning and backward propagation based learning techniques, right? So you have things like Siri and Alexa, which were the first generation of narrow AI, but now you have ChatGPT, which sort of borders on general intelligence, but not yet there, right? I just put this here just to show that it starts, but it necessarily comes into this area, right? So another sort of view look at artificial intelligence is you can look at it this way, right? Rather than looking at the functionality of it. AI can be vision AI, speech AI, language processing, expert systems. So expert systems are like, medical systems where you can feed it information and it will give you an answer of a diagnosis, things like that, right? Robotics. So robotics is an entirely different field, right? Boston Dynamics, they create robots that can mimic human behavior, that can, do flips, fall down, get up, jump around, things like that, right? And machine learning is for predictive and deep learning. So this is where data science cuts into AI, right? Specifically narrow AI, right? So that's what we need to be technical. So AI and data science. So if you take AI, so I will show you in the next slide. So this is again some applications of AI. So ChatGPT everybody knows about, but what people don't know about is there are many other AIs out there that are far better than ChatGPT, right? Try some of these out, and it will amaze you the results that you get, right? ChatGPT is blown away by some of these other AI, right? But ChatGPT marketed well, so that's what happened. But these other things is very. So I didn't put Canva here. So the Canva AI creates very beautiful lifelike images, right? You can ask, if you give your image and say that create an image of you shaking hands with the president of the USA, and it'll create that for you, right? And it's pretty authentic in that sense, right? And the other part, as I said, is on robotics, right? The Spot, just Google this and see, right? Spot Mini and Atlas. I mean, it's amazing what these robots can do. So that is one part of AI, right? But when you build the ability to learn into this, right, that becomes sentient, right? Because that is then it's aware, right? It's aware of its surrounding. It can react, right? So that's I would say that's long way ahead, but maybe in the very near future we will see that, right? So that I think that resonates with these definitions, right? So this the one that we are talking about, ChatGPT, is just here, right? Language processing. So it's a language processor. You can ask it something, and it has the ability to process what you're asking and give you an answer, right? So it's in this area, language processing. But there are a lot of other areas in AI, right? And so all of these cut across also the NLP engine. So once you understand the query, it will be passed on to an ML engine where it will learn from the data that it has been given and give you an output, right? So all of these things will be interconnected as well, right? But as I was saying, so there will be vision, speech, expert systems, robotics, and it's pretty amazing what some of these robots can do, right? If you Google this up and see Boston Dynamics Spot Mini, and the Spot Mini is actually now being put to work, right? Some people have adopted it as pets also, but it has far more capabilities, and it's pretty amazing to see, right? So ChatGPT is just the version on the computer, but now people are transforming ChatGPT into Spot Mini and the Atlas, so that it can interact, right? It'll know the history, it'll know what you're asking it, right? So it'll be a crazy thing, right? So finally, I just wanted to show these two interactions, right? So data science, as I said, will have a machine learning that we talked about. It'll have data analysis, right? Reporting, presentations, and all that. It'll have data visualization, and you have artificial intelligence on the other hand, right? So artificial intelligence, as I showed you, has three parts, right? Narrow AI, general AI, and super AI, right? So this narrow AI, as I showed you earlier, it is built on machine learning. So machine learning comes from this data science discipline, right? So this is how these two things actually interact with one another, right? So if you want to move into, so mind you, artificial intelligence is a beast. It's a massive area, right? But you can take a step into it when you do data science, when you do machine learning, when you do higher concepts of especially reinforcement learning, deep learning, concepts like that. You are stepping into the realm of AI, right? And then you can start in there. But as I said, data science is sort of a precursor for you to go into AI. But this is how these things are related. And finally, I just wanted to leave you with this thought. So what is important in a journey to data science? We might not be able to go to, being the part of the team that builds the super AI, but we might be able to go to a place where we are happy with ourselves in achieving, right? So I think what is more important than the knowledge is the commitment, the enthusiasm, the dedication, and the curiosity that you have to have. Because nowadays, if you had realized, knowledge is free, right? So if you take this presentation and Google it, you will get hours and hours of information, courses from Coursera, Udoreka, you name it, that might be free, that you can learn all of this, right? So knowledge is free. Knowledge is no longer a sellable commodity. So but you need to have this analytical mindset and strong ethics, right? Because as I said, AI is a dangerous thing. That's why people have, banned it even in some other countries. Because if you don't use it properly, AI is a dangerous tool, right? So ethics is important. You should not ask it to do because things will evolve, right? People will figure out ways to do this. People will figure out a black darker version of chat GPT where you can get an answer to anything, like the dark web, right? Who came up with the dark web? Nobody knows, but people are using it, right? And people say, I'm using the dark web only to download books, right? I don't know. So dark web is dark web. So dark AI is inevitable. That's human nature, right? So I would advise you to have a strong ethical core, because this is seriously a different era, right? I'm also confused as to where this is going. But what I can tell you is that we can, we can help you if you're not familiar with these concepts. We can teach you what we know. We can discuss things with you, and then you can, take it forward from there, right? So these are some of the skills. As I said, ethical skills is very important for a data scientist, as I was saying. Maths and statistics, coding, data wrangling, pre-processing, visualization, machine learning, real world project experience, communication skills. You should be able to communicate your answers to people. You should be able to do presentations, convince people, right? Lifelong learning, team player. You can't obviously be a single data scientist that has a solution to everything, right? So that's how it is, right? And so in conclusion, I would say that so that's pretty much sort of oh, sorry, this is sort of pretty much what I had to say, and I just wanted to thank you for your So let me just share my screen and then do the concluding remarks. Can you guys see my screen?
Yes, we can.
Yeah.
Yes.
Oh, sorry about that. That's what we are talking about, AI, and the bloody power runs off. So that's funny. Anyway, so as I was saying, I just wanted to wish you all the very best in your journeys in learning data science and AI. And I just want to leave with this quote by Andrew Ng. He's a very respected personality in this field of AI and data science. He has done a lot in deep learning. So he says that and Andrew Ng is the co-founder of Coursera also, right? You have a lot of courses that you can try for free in his that, and he has done a lot of other work that you can see and you can use as well. So he says that, I think he's the most prominent authority in machine learning right now. So he says that AI will be the new electricity, right? We know how electricity is important to us, right? We all know how we struggle when we don't have electricity. So he says that AI will be the new electricity, so that says a lot, right? So with that, I would like to thank everyone for their time and patience in listening, and thank you very much again for being here. And I'm sorry for running a bit late with the presentation. So I would be more than happy to take any questions if you have. Thank you very much.
Thank you, Dr. Harshana, for the most insightful presentation that you gave us. All your slides and everything was really clear, and you put a lot of things in perspective, because getting past the movie buff interest that we have in AI, you just got down to the bare bones of it and explained how data science is the bedrock of AI. So you also gave us, walked through the whole process of how data science is the precursor for AI. It's AI has been around, it has been around for some time, but it has only garnered interest in the recent past. Maybe it has been around, maybe around somewhere around the 1950s, because the very early robots, right down to what you said on narrow AI with Siri, Alexa, and all of that. So you put a lot of things in perspective, and I personally gained a lot. There was a lot of takeaways, and I hope it's the same with the others. So yeah, thank you for your time, Dr. Harshana. So thank you for all the bite-sized knowledge and all of that, cutting past the glitz and glamour and breaking things down for us. And also explaining the more technical stuff, cutting past all the technical jargon and explaining it in a more simple, easier to understand way. So yeah, so now's the time to go for the next part of the session, the Q&A. So we'd like to entertain any questions from the audience. So if there's anything that you would like to ask Dr. Harshana, now's the time. So,
sir, good afternoon, sir.
Yeah, Dr. Harshana, we have a question there. So,
good afternoon.
Sir, good afternoon, sir. I am Roshan. Sir,
good afternoon, Roshan.
Am I audible to you, sir?
Yes, you are.
So first of all, I would like to thank you regarding your presentation. It is very much grateful, even though you didn't go very deep, but the points you mentioned are really worthy. So a person really who wants to enter into this DS and AI career, so these words and key areas are very fruitful to them, according to my point of view. Then of course I have a question regarding this data science, because I am one of a person who is looking into enter this DS career. So will AI replace data scientists? That means, according to this presentation, along with the development of AI, I thought a little bit kind of that once a day AI will replace this DS. Is there any interconnection with AI and DS? So DS will be a very much important thing, or very much important pillar for AI. That means AI cannot, as example, AI cannot live with DS like that thing. Is it happens in future, or can you explain a little bit about that?
Yeah, sure. Thank you, Roshan. Thank you for your very kind words, and I appreciate the feedback, and you're very welcome. So in terms of this, you are spot on. I think data science will it'll be absorbed by AI, right? Because even though data science gave birth, or sort of data science sort of paved the way for AI will definitely absorb it, because end of the day, now if you are a data scientist, what would you do? You will take a set of data and write a code to interpret it, right? So that part AI can do very easily, right? Now, even now itself, it can do that, but it has not yet gone into the level of it cannot tap all the sources of data that is available. It cannot talk to people and build the domain knowledge. So there is still that part. So the domain knowledge pillar, it might still be there, because the problem specification, data sourcing, all of that might still be, human intervention might be needed. But as you said, beyond that, when you have a data set, you can simply instruct an AI to do the ETL process, you load it, maybe to Hadoop cluster, do the Spark analysis, get the information, and then put it onto an R or a Python, and then get that information fed into a Tableau or a Power BI for visualization. So the computer will always be an AI engine, right? So whatever you do with a computer will be automated, and it'll be, an AI will always take care of it. But what you do beyond a computer, of course, might not be able to be replicated that easily by an AI, like the initial discussions, the objectives, the source findings, or the interpretations. But as I'm really, I don't know, if, as I said, AI is at an infant stage, right? So when the AI evolves, all of that also might be possible, because as I was saying, our awareness, probably my awareness, now I don't remember my school days or when I was, what I did when I was at grade 5, but an awareness based AI will remember everything, right? So it'll look at the entire history of the mankind and maybe suggest the objective of a data analysis to you, right? So it'll definitely go on to that level, but still, I don't think that we still have that sort of sentience where we are building programs, right? But that's coming. I'm not sure whether it'll be in the next 10 years or 15 years, but obviously there wouldn't be, as you know, right, marketeers are being replaced with ChatGPT, optimizers are being replaced, QA, there's a company that I know, there were 80 QAs. Now, all of those, out of those 80, 60 QAs are now in trouble, because now ChatGPT has a interface to many other languages, so that you can give that code to that interface, that extension, it'll show you all the errors. So what it took so many QAs to do in 6 months, ChatGPT has now done it in maybe 5 to 10 minutes. So that kind of disruption is there in the industry. So as you're saying, data science will also get disrupted. But I don't see that happening, probably not within the next 10 years. Because that requires a different level of, because we are not there yet now. The other stuff, the infrastructure is not yet ready to build the sentient AI, right? You don't have that data retention capacity, you don't have that retrieval capacity. So even with the highest technologies we have, or the highest bandwidths we have, still it will be too glitchy. So that also has to develop, but when there'll be a moment that things will come up. But as you said, so learning AI, there's no entry point. So learning data science will actually give you that entry point, in my opinion. So I hope that helps. There are some other questions.
Yes, Dr. Harshana, I think we have one question from Chamat here. He asks, when introduction of MS Copilot, what will be the data science field? Is it worth learning coding and all? So I think it's better if I just copy that and paste it so that everyone can see it. And we'd encourage more questions because we are in a bit of a time crunch. So if you can make sure that the questions are coming in fast, Dr. Harshana can answer it. So this was Chamat's question.
Okay. Of course, if there are any other questions, I would be more than happy. I mean, if that can be circulated, I can get back at a later time. When introduction of MS Copilot, what will be is it worth learning coding and all? Well, I mean, yeah, Copilot is taking a lot out of the analytics that we do, but still, I think, as I said, the part, Copilot cannot identify the sources, clean it out. We still have to give that instruction. It'll follow an instruction, right? If you say, impute all of the missing values using an average, it will do that. But to say that, right, to know that you have to impute or replace the missing values from an average or a median or a mean, that knowledge you should still have, right? So then only you can compete with stuff like this. So if you don't learn coding at all, or not coding, I mean data science or those advanced concepts, then you will be just a tool for this tool, right? So I don't want you to be that. So what I'm saying is always, challenge yourselves and learn what you have to learn, because maybe not coding, of course. I also now use ChatGPT to do analysis using Excel, because I ask it to write functions and it'll do that. So it helps me in that way, right? So I don't see that as a potential threat or a missed opportunity. But I still think I need to train my mind to be able to think algorithmically or analytically. So in that sense, I would still think that, coding, not learning coding, not coding, as I said, programming is about those 6 constructs, right? You need to understand those constructs, not coding. So once you understand it, you can ask ChatGPT to write the code for you. That's fine. But you need to have that what to apply where sort of mentality. And that is important. So I think, yes, so for that question, I think still it's worth learning, right?
Dr. Harshana, we have yet another question, and this time it's from Edwinat. I'm not sure whether I'm pronouncing the name right, but he has a question for you. Yeah.
An understanding of how would you say an understanding of data analytics would help someone who is keen on becoming a machine learning engineer? Okay. Like you said, when it comes to fine-tuning a model, knowing what set of data you have to deal with, how to optimize it. Data analytics. So obviously, I think so you're talking about the role of a data analyst and a data engineer. Sorry, data scientist and a data analyst, right? So I think the first part is, I think if you have gone through a proper channel, data analyst is the lowest of the two, right? Data scientist is the one who will select the machine learning algorithm, load it, and tune it. But as you're correctly saying, when you're coming from a data analysis background, you should have an understanding of the domain that you're dealing with, right? At least some understanding. I'm not saying that you have to be an expert, but as I said in the previous example, so being a data scientist is a great thing. So you can apply that knowledge everywhere. But let's say you're consulted to do a medical analysis, and obviously you will not be qualified to do that analysis. So then you would have to have help from maybe a data analyst in the medical field or a doctor, and then you have to understand it, understand the data that you're processing. So that is always important. But I wouldn't say that data analytics is a separate thing. It's something that you can learn through experience, and the more projects you will do, the more experience that you have, the more interpretations that you can do, right? So I think so that data analysis is the easier of the two. So if you're a machine learning engineer, that you can apply coding and sorting and machine learning to get an understanding of the data. So that basically is good enough, so that you can get the help of an analyst to interpret that, right? And if you can, because if you know machine learning, obviously data analysis will be a piece of cake to you. So if you can learn something about the arena or the domain that you're working in, that will be an added advantage, I think. But it's just not one or the other, in my opinion. So because a data engineer or data scientist will have to work in multiple domains, not just banking every day, not just medicine. So build your knowledge that way and get help from people. So I think that's my opinion on that.
And also, Dr. Harshan, I think there's a note of appreciation from one of the participants. Manoj here says, thank you, Dr. Harshan, for this great session. Please share with us the recording. It will help for us to dig deep in this. So along with him, like we had 2 others, Roshan and Priya, asking if we'll be uploading the recorded video. So yes, like you can head to our Kinsley YouTube channel and it's available on it. So you can just find it there. So in case you feel that you might have missed anything or like you might have to like, listen to it again, then you can just head over and listen to it again. So yes, again, Epinath has thanked you. So any other questions, guys? So we can like take a few more questions.
Hello, can I ask a question?
Yeah, sure.
Firstly, thank you, Dr. Harshana, for this great session. My question is, there is a new subject called prompt engineering with AI application like ChatGPT, Midjourney. Can you give an introduction about it and how important is it to learn?
Sorry, I didn't get that first part.
Hello?
Yeah. So, sorry, I'm having a bit of issue with my connection.
Okay, my question is, there is a new subject called prompt engineering with AI application like ChatGPT, Midjourney. Can you give introduction about it and how important it is to learn it?
Prompt engineering, you're saying?
Yeah.
I'm sorry. I mean, I don't exactly know that terminology. So, I mean, I have not come across that. But you're asking whether learning about that particular field or learning about AI in general. So if it's about that particular field, I'm sorry, I'm not really very much familiar with that. I'm sorry about that. Maybe I might be able to get back to you on a different time. Probably if your contact is there with the Kensley team, I would definitely get back to you. But at this point, I'm still sorry. I don't understand that concept. But in terms of AI, again, it's a debate, right? Some people are actually, promoting AI. Some people are saying it's a bad thing. So, but I think it's good to understand what we don't really feel comfortable with, right? Because I think it's always good to be understood before we make others understand. So I think in that way, it's good to be a part of this, right? I'm sorry about the other part. I'm really not really sure on that area.
So like we are in a bit of a time crunch, like I said, no, this session was supposed to go on till 1 hour, but like it's been going on for like more than 1 hour. So it shows like how interested you are in it. So and apart from Epinath, like we have quite a few others who thanked you. So Rupika, Eranga, Akila, all of them, thank you for the contribution that you made, and Dasni as well. So thank you, everyone. Thank you for tuning in, taking the time off your busy schedules, including Dr. Harshan. I know how busy a person you are. So you are out of town yesterday and you are back here exclusively to do this. Thank you for everything. Thank you for all the useful information that you've given us. And also to our participants, in case you are interested in a career in data science and are looking to level up in your career with a British qualification, or thinking of adding qualifications to your CV, you can consider PGDeep or anything PGDeep in data science or AI, whatever your interest is. So for more information, you can contact Kinsley. So you can follow us on our socials. We are available on Facebook, Instagram, and our YouTube channel. Yes, of course. So some of them had asked for the recorded video. So you can head over there and it will be uploaded sometime within the week. So you can just head over and go through it again. So the appreciation keeps coming in. So again, Kaishara, thank you, sir. And Mr. Sajid himself has thanked you, Dr. Harshana. He says, thank you very much, Dr. Harshana. So on behalf of everyone, I also thank you for everything. So thank you for the most insightful session. It has been most interesting. Like I said, I'm a movie buff myself. So everything that I know about AI has been like I said, I've been thinking, okay, data science and artificial intelligence, they're like, two twins, with AI being the popular twin. So you've broken down a lot of things and explained a lot of things. Like I said, have learned a lot, and I hope the others have as well. So thank you, everyone. So let's wrap up. So signing off.
Thanks, Adira. It was a pleasure to be here. Thank you very much.
Thank you.